All right, now today is about how we use resistance in problem solving. Since we already know the units and symbol for resistance, you know those, right? What's the symbol for resistance? It's an omega, right? And the units are ohms. So since you know that and you know how resistance is created, it's sort of like friction, electrons running through wires. Do you remember if small wires or large wires actually have less resistance? Turns out large wires do. So that's what we were doing in the last lesson, is we were getting the qualitative ideas that we were going to need. And today we're going to start looking at the math part of it, which is how to use Ohm's law. Potential equals current times resistance. Remember, I is current, V is volts, which is electrical potential. And it's a very simple equation. So as you can imagine, with a lot of these, being a sophisticated group of physics students, I'm going to ask you to work ahead and solve the problem and then check the answer. And you can predict where things are going to go, which is we're going to start integrating Ohm's law with other equations we've learned in the past, like the power-related equations. And I want you to apply all those great skills you have. The key to success in all of this, since you're really good at the algebra part, is you have to know the units of each one of these values. If you're not sure what the units of current are right now, it's amps, right? Then that's what you have to brush up on. Is very often people put values in the wrong place. Okay, so we have Ohm's law here and we have our power equation. Those two could be interrelated. And I want you to look at this problem and decide, can it be solved with one or the other of these, or are you going to need to integrate them in some way? So stop the video here and I want you to solve the problem on paper. All right, I got 2 amps. Is that what you got? Well, let's see how we would solve it. Let's label our values. Clearly, this is volts. 3 omega, you remember that's an ohm, that's resistance. Let me just put an R there. And they're looking for current. What symbol is that? Well, that's I, right? So we have volts, we have resistance, we have current. We have resistance and current, and we're solving for I. So we know volts, resistance, and we're solving for I. It looks like Ohm's law is all that we need. We can plug in our 6 volts right there. We can plug in our 3 ohms right there, do a little division, and we get our 2 amps. Easy peasy. The voltage is always the potential difference across some load. Very often it's not through the whole circuit, it's across some load that we might be interested in. The previous problem only had one load, but we're going to look at some that have more than one load. Okay, so if you have 2 identical light bulbs in a circuit, so now we have 2 loads, and it's a 6-volt battery, what is the resistance of each light bulb if the current is 12 amps? So this trick is integrating something that we learned a little bit earlier, so I want you to see if you can figure out what the trick is and calculate the answer. Did you get 0.25 ohms for the resistance of each light bulb? Well, let's see how we might tackle that. The trick here is that if it's 6 volts, you remember it's 6 volts all the way up to point B, and then, it's yellow is not a good choice here, is it? And then at that point, it has to drop in voltage, and we know that by the time it gets back here, it has to be 0 volts. If the 2 light bulbs are identical, they have to consume the same amount, so I think each one will consume 3 volts. So now we know the volts of each light bulb, and if we want to know the resistance going through one light bulb, we know we have 3 volts. Blue is not the best color now, is it? I'm going back to yellow. 3 volts. We know that the resistance is 12 amps, and we're trying to find out, the current is 12 amps, and we want to know what is the resistance. So we know volts, we know current, we have 3, we have 12, and we can solve for that by dividing by 3 divided by 12, and we get 0.25. So that's integrating that idea that each load consumes a certain amount of the voltage. Okay, let's go on to practice number 3. I'll let you read it. I want you to see, do you need 1 equation, 2 equations, get things labeled properly, and solve it. All right, did you get 2.5 ohms for the answer? If you didn't, then remember the trick here is, I know this is volts. 10 watts is a measure of what? What? Anyway, it's a measure of power, right? Watts is a measure of power. It is not work. Even though we might have the work equation, you remember power equals work divided by time. I think you'll see that come back in a second. Work is not a measure of, or watts is not a measure of work. This would be joules. So we know P, we know V, they want to know how much resistance. So if we have P, we have V, and they want to know how much resistance, you can see that we need to solve for R here, but since we don't have the current, we can't use this equation, and R isn't in this one at all. I think we're going to need to do some solving of one, maybe plug it in and come this direction. But even down here, I know the power, I know the volts. I guess I could solve for I. That's one solution, right? I could do 10 watts. I could do 5 volts. I could divide by that and I'd get 2 amps. I could plug my 2 amps in here. And I know the volts are 5 volts, and then 5 divided by 2 would give me my answer of 2.5. That's one way. If you were a person who said, look, I don't know current in each spot, I could solve them both for I. I could say I equals V divided by R, and then the other one I could say I equals P divided by V, and then I could set that equal to that, V over R equals P over V, and then I have all my variables in order to solve for resistance, right? We'd be solving for that. So that's another way you could do it. And there are times when that's the only way. You have to set equations equal to each other. Okay, this one you can clearly see I'm saying is a good challenging problem. I want you to pause it here and see what you get. Did you get 3 amps? If you didn't get 3 amps, let's walk through it. Well, one trick is to remember that watts is power. We know the resistance. They want to know current, and current is I in amps. We know power right here. We know resistance, and we want to find current, and current's in both equations. Well, we don't know the voltage, so we can't use this equation, and we don't know the voltage, so we can't use this equation. This is an example where the only way you're going to do it is by setting them equal to each other. Now, of course, the question is, which variable do you solve for when you set them equal to each other? In that last example, I solved for I. I was in both equations. I could solve it for I, and I could set them equal to each other. But why don't I want to do that here? Well, the answer is because I'm trying to solve for I. If I solve both equations for I and set them equal to each other, I wouldn't have any I left in there. So I've got to solve for something else. And you can see the only other variable that's in both equations is V. So if I have V equals IR in this first one, in the second one I want to solve for V, so I'm going to get P over I equals V, right? All I did was divide both sides over here by I. And now V equals these two things, so that must be equal to that. So I can do P divided by I equals I times R. I'm solving for I, so I can't have them in two different places. So I'm going to multiply both sides by I. So then I'll have P equals I squared R. Now, since I'm solving for I, I've got to divide by R. So I'm going to get P divided by R equals I squared. And then, of course, since I'm solving for I, I've got to square root both sides. So I get the square root of P over R equals I. So all I have to do is plug in my 90 watts for P, plug in my 10 ohms there. That'll give me 90 divided by 10 is 9. Take the square root of 9, and I get 3 amps. So that's a tricky one because that one you had to solve the variables simultaneously and set them equal to each other. Okay, there's another one. Go ahead and practice it. See, there are 1 or 2 tricks in here, and you can see that I've added in the third equation. Maybe you only need 1 of these. Maybe you need more than 1. Maybe you need 2. But I want you to do a little problem solving and then come back and check the answer. Matter of fact, I'm going to put the answer up right now so you can work towards it. Okay, if you didn't get 405 hours, there are a few things we should look at. One is there are some unit conversions in here. Yes, I thought I had 120 volts, but 6 megajoules, that's megajoules, is 6 million joules. 3.5 kilo ohms, remember I've got to multiply by 1,000 to get 3,500 ohms. And I'm solving for time. But you know time is going to come out in seconds, and they want it in hours. So units were a big deal here. Now let's think about problem solving. I think that they're giving us volts and resistance. We could solve for I. So that's a possibility. In the end, they want time, so clearly this equation is going to be important, and that equation is going to be important. But the question is that enough? Well, if I solve for current, you know there's no current down here. And to solve this one, I know work, but I don't know power. So we could use these two values to solve for I. So I would have 120 volts, I'd have 3,500 ohms, solve for I. Now I know I, and I know volts, I could find power. And once I know power, I can plug it into this value here and solve for time. Now let's talk about the algebra on the bottom. Remember, whenever you're solving for a variable on the bottom, sometimes that can trip people up. You want to multiply both sides by t. That'll give you P times T equals W. All right, so that's how you solve that one. So you can see that there are some times when you can do sequential problem solving, like we did in that last one. Some problems, you can just kind of go one variable to another and keep working your way through it. But keep an eye out for those moments where you have to solve the equation simultaneously. Some problems require solving for the unused variable, and setting them equal to each other can be the only way that you can figure out the answer.